Hello and welcome back to the last part of lesson 24. So hypergeometric distributions. The example, 100 widgets. Widgets are just a generic term given to a product in economic terms. So 100 widgets are produced by a factory. 5% of the widgets are known to be defective. If 8 widgets are randomly selected and tested, determine the probability that A, none of them are defective, and B, at least 2 are defective. And there's that at least term that we all have come to not appreciate. So, A part, let's deal with our values. Why is it hypergeometric distribution? We're taking a widget out, we're testing it. It can't be replaced back to the line. I don't want to test it again. I already know it's defective. So it's taken out, so it is dependent events here. Okay, so what do we consider successes? So our A value is the successes, and that is defective widgets. So 0.05. 5% times, we're testing 100, so that leaves us with 5 defective widgets, which would mean that there are 95 widgets that are in perfect working order. Our N value in this case, we want to determine the number selected. We are selecting 8, and the X value will depend on the question. So for A part, none of the widgets are defective. So that means that our independent variable defective widgets, in this case, will be 0. So now we can plug it into our formula. Number of successful items is 5. We don't want any of them. 95 unsuccessful items, and they are all in perfect working order. So the 95, the 8, and we're dividing that by 100 were tested, or sorry, 100 were selected, 8 were tested, and we do the calculation. And for people, I apologize, in the previous example, this is what it would look like if you're writing it out in the other format. Doesn't matter which one you choose, stick with the one you're most comfortable with. I'm not asking you to switch. I just sometimes forget that people prefer the other one as well. So doing the calculation quickly here. 35, 8, divided by 100, 8. So I get 0.653. So therefore, there is a 65.3% chance there are no defective widgets. All right, so straight calculation, how many are defective? In this case, we're hoping for none. And we find that there's a 65% chance that out of those 100 selected, and 8 from that group of 100, and that they are, in fact, in good working order. B part. A and B don't change because we're looking at defective widgets still, but at least 2 are defective. So that means our X value is at least 2 would mean 2, 3, 4, 5, 6, 7, 8. I don't want to have to add up or do all those calculations because we'd have to take this particular formula and we'd have to repeat it for 2 through 8. So here's an example of an indirect. We're going to go the opposite direction. And what we're going to do is we're going to take the probability of X being greater than or equal to 2. So that's what the question wants. How many, or sorry, at least 2 widgets are defective. And we're going to switch it around and take 100%, and we're going to subtract the opposite. What's the opposite of X being greater than or equal to 2?
Please remain in your seat till the bell rings. You announce.
Okay, so what's the opposite of probability of X being greater than or equal to 2? Well, it would be the probability that X is less than 2. So we need to list all the values that are less than 2. Well, the only one that's less than 2 is X equals 1, and X equals, sorry, it should be still subtraction, minus X equals 0. So having to do 2 calculations right here, are a lot better than having to do these 6 calculations out. All right, so the indirect method is a little bit quicker for us. So just moving over here, 1 minus, so the probability of 1 faulty widget would be 5, choose 1, 95, choose, oops, sorry, 7. Divided by 100, choose 8, minus 5, choose none, 95, choose 8. And that last one I kind of like because I already have that calculation completed. So 1 minus. Extend this page down a little bit. So the last one I know is 0.653. And now I just have to do that intermediate calculation. 95, choose the 7, divided by 100, choose 8. I get 0.297. Cleaning that up, 1 minus the 0.297 minus 0.653, 0.05. So therefore, there is a 5% chance of there being two or more defective widgets. There we go. So there's an example of using indirect methods similar that we talked about in the first unit. All right, so there is that example. One last example to complete. All right, finishing up the final example here for hypergeometric. 1,000 fish in Lake Ontario were caught and tagged. So they put a tag in their fin. 1 year later, we went back and 500 fish were caught. 60 of the 500 ended up with tags, so that means they were part of the original 1,000. Determine the estimated population of fish in Lake Ontario. So if you ever see a survey or a report that says this is the number of caribou or moose in the north of Canada, you don't actually have a person go out and count them one by one. They use this hypergeometric approach to come up with the actual number of the population. So we're looking at expected value, and your expected value formula for hypergeometric, sorry, is n multiplied by a over a plus b. So it's just a matter of identifying n, a, and b. So remember, a is the number of successful items that exist, or number of successes that are out there. So we tagged 1,000 fish. So that means that there is 1,000 possible successful fish out there for us. B is the number of failures. Well, we don't know how many fish are untagged, so that's actually what we're looking for. This is our unknown right here. We don't know how many failures are out there, fish that don't have tags. So that must mean that we know all the other pieces of information. So I need to add expected value over here because we must know that particular value. So what we're doing is we're kind of reversing it a little bit. How many fish were caught? What's our population? Well, that's your n. Your n value is your sample size. So we had 500. What's e to the x, the expected value? Well, expected value in this case is your actual value. So in this case, it became our actual value. And what that means is this is the expected value. So 60 is our expected value when we have this many failures out there, which we don't know. So the expected value is 60. We're trying to figure out what value of b will give us that expected value. So once you wrap your head around that, the formula becomes 60 equals 500 in our trial. We know that there was 1,000 possible successes over 1,000 successes plus how many failures. So going back to your grade 11 math, we just want to get rid of the fraction. So this value gets multiplied up. So I'll do it in steps here. So it'll be 60 multiplied by 1,000 plus b, and your 500 times 1,000 becomes, I get the right number of zeros there, okay, 500,000. Using distributive law, we're going to solve for b. 1, 2, 3 plus 60b equals the 500,000. Subtract your 60,000 from each side. Just using algebra skills from grade 9 now to solve for b. And we end up with our 60b equals our 500,000 minus the 60,000. So 440,000 obviously. That's what happens when you do this on Mondays. And oops. Final step then is divide by 60. So b would equal division 733.3. Now obviously again, I can't stress this enough, use common sense. You can't have 0.3 of a fish. So therefore, there are 7,333 untagged fish. Untagged fish. So therefore, 733 plus the 1,000 that are tagged, 8,333. So there are 8,333 fish in the lake. Okay, so this is how wildlife studies work. They tag some, they come back in a year, and they use this reverse hypergeometric calculation to determine that value. So, just finishing this up, that's your hypergeometric. So we're at the end of our geometric distribution, or sorry, our distributions that involve discrete values. So what I have here on the final slide when you print it out is a summary of the distribution type, a brief description of it. I provide you with the probability formula, and I provide you with an expected value formula. Now you can make the additions or change this accordingly because obviously it's for your study purposes, but those are the ones that we've covered so far, and those are the ones you're responsible for. At the bottom here you find the assigned homework. If you have any questions, you know exactly where I am. I'm in the front of the room looking for someone to help. So we will talk to you in a future